Hi there, and welcome to this short and sweet video on the topic of sound waves. We already know that sound waves are longitudinal waves which are produced by the vibration of an object. As the cone of a loudspeaker vibrates back and forth, it forces the air particles in front of it into oscillation. Regions where the air particles are closer together at a given point in time are called compressions, and regions where they're further apart are called rarefactions. The same process happens when any object in air vibrates back and forth, such as the string of a guitar, the skin of a drum, or the vocal cords in our throat. Of course, sound waves can also travel through liquids and solids. In the next video, we'll be looking at some of the useful applications of this fact. So how do we actually hear a sound? When a sound wave enters our ear, its compressions and rarefactions set the eardrum into oscillation. As it oscillates, the small bones which it's connected to are also set into motion. The last of these is connected to the cochlea. Inside the cochlea, this vibration leads to the production of an electrical signal which is sent to the brain via the auditory nerve, which is where we get our sense of hearing from. Who would have thought that listening to the sound of my voice would have been such hard work? Just as a musical instrument has a lowest and highest possible note, our ears can only detect sounds within a given range of frequencies. You may know that humans can only hear sounds in the frequency range from 20 Hz to 20 kHz or 20,000 Hz. As we get older though, our hearing deteriorates and the range of sounds we can hear gets smaller. Our ability to hear high frequency sounds in particular gets worse as we get older. There are a number of reasons for this hearing loss, but the most common one is that the cochlea, the important bit that converts vibrations into electrical impulses, becomes less sensitive to high frequencies with age. Non-human ears can hear frequencies which we can't. Whales, for example, can hear sounds as low as 7 Hz, while dolphins and bats can hear up to an incredible 160 kHz, 8 times higher than the maximum audible frequency to humans. The way in which our ears work is actually quite similar to the way in which a microphone works. In a moving coil microphone, sound waves strike a flexible diaphragm and set it into oscillation. This movement leads to the production of an alternating electrical current in the connected wires, which can in turn be amplified and used to drive a loudspeaker. Notice how the energy conversion is occurring in both devices. The ear and the microphone are exactly the same. The kinetic energy of the vibrating air particles that make up the incident sound wave is converted into electrical energy. That brings us to the end of this video on sound waves. Thanks for watching and good luck.